Okay, so before the break, we were looking at the way of writing Python objects classes that is generally considered better form. It translates to other languages better. We don't have private in Python. We saw how we can still access them directly, but we treat them as private. And that way it's more like our other languages. But we don't have private data. So a lot of people also just use the easier version, which is what our textbook does. So I'm going to redo this stuff with the easier notation here. So make a class called human. Oh, there's somebody. I'll give it a second for his mic to keep it on. Oh, that's quick. Okay, so when Zoom, I guess Zoom or the internet kicked you off for a second there, we were just getting back to this. So it's an important point to reiterate. What we were looking at translates better to our other languages. It's considered better form. You will see it around, but most people just go ahead and go with the easier one we can have in Python. Since we don't have private data, we can still access all of it. So a lot of people are just under the belief of why fake it, that sort of thought. So we can just use the easier notation like the book does. We'll still need similar things, like we still need our init method. The first parameter still has to be the thing we are designing here. Okay, the screen's way backed up for me. It's showing the screen share from that. Can you all hear me okay?
Yeah.
Yeah, you're good.
Okay, yeah, the TV monitor, our great big video thing in the room, for those who haven't been back to campus yet, there's big, like, it might be a 72-inch screens. We got two of them in the room, one in the front and one in the back. But the one on in the back of the room was like 30 seconds behind when I was typing. Okay, so the thing we're creating, designing, making a blueprint for still has to be first. And I'm just going to duplicate what we did above. Name, age, and town. So we'll pass in the same parameters. And we still need to reassign them here. We can just make them regular data fields. And for those who have had your DBMS 110 class or seen databases somewhere, it is not a coincidence that we use the same name as we do for database tables. We're not going to get into all of that here. If you think about it, it should start to make sense and be somewhat obvious. But it is definitely not a coincidence we use the same name as we do for database tables. Nor is it a coincidence that, oh, it's on the other file. Nor is it a coincidence that when we import stuff, that looks an awful lot like a SQL query, right? For those who have seen it. Those connections to a database are not a coincidence from the internal workings of Python and how the interpreter works and stuff. But, not really for what we're looking at tonight. We're just copying this down. So we can just make them regular data fields, not static data fields. And that's an important word in programming. First time we've used it this semester. So to reiterate, static means there is only one copy and only ever will be one copy. And if there's only one copy, we can use the one of the class, not the one in an instance of the class. We can go back to the blueprint, not the thing we make from the blueprint. Which is why our constructor, the init method, has to be static, because there's nothing there to call a method from. So we have to go back to the blueprint where there is something in order to call it. And yeah, static means only one copy, which fits the normal use of static, right? Like this wall is static, it's not dynamic. there's lots of forces on it. The weight of the roof pushing down, air pressure pushing up against it. I don't really see anything in here, but we could lean up against, I could lean up against the wall. This board's hanging on the wall, which actually pull it down. So there's lots of forces on it as far as like the laws of physics are concerned, but it's static. It's not moving. It's not changing. So one copy, it does not change. So it kind of means the same thing. And once we have those, well, we can do the same stuff. What did I do in my example? Should I do the string method? When I was getting ready, I didn't really make any changes here. The string and the equals method would be exactly the same. And our book really like to use those getters and setters. So maybe I'll do something with the getters and setters here. I'll do it in the child object. So that'll be good for the parent. We can go make an instance of that or go ahead and do the subclass because all the concepts are still the same, but it's no longer private data. We don't necessarily have to have our getters and setters. We need those, and we needed those earlier because private data does not get inherited. And in this case, the Python programming language is actually set up for that, act like it's private. They take that into consideration when they made the language. So that sort of static, semi-static stuff doesn't get inherited just like private stuff. So we couldn't use the name variable earlier in our string method. But public data does. So another name, I already used person and individual. So I'll go with like human and citizen this time. And once again, the keyword class. Then what's unique to our situation, we have this citizen, and the starting point, what we're going to begin with, is everything that we can inherit from that human class we just defined. Then we can set up our constructor for this the same way. So what's in it? Well, as itself, those things that inherited. What else do we need? Gender and race. I'll do race this time. Ethnicity kept leading to typos. So I'm not necessarily, I'm going to use it the same. I'm going to use those words interchangeably, basically. Lacking synonyms, and that's a common way to split people up. It seems like it fits the gender. It would go into the same sort of database table. And then we need the stuff for the parent object. So our args and quarks, which just, once again, as a reminder, it's the asterisks and two asterisks there that actually matter. The rest of it is just a reference name. And that's what he used when he created Python originally, way back in Christmas break of 1989, when he couldn't get out of a family event and made up a work project to get out of talking to people, at least. Interesting origin for Python. But by the end of the week, he knew he had something, he knew he was onto something really, really good. It did not take, once computers could handle it, it very quickly became the most popular language in the world, by far, because of this, what we're doing here. Once again, we can just pass that stuff right up to the super. We'll call the constructor on the super without passing anything in. And since this is a child, we have better access. And using parent-child terminology, right? The general public doesn't have access to your parent's bedroom, or to a child's bedroom, but a child does have access to their parent's bedroom to some extent, or other spots in the house. Maybe something that's not normally used, the attic. The general public doesn't have access to your own attic, but the people in your immediate family, parents and children, do have access to the same attic. And whoops. Then we'll pass those args and quargs right back up to fill those, and then set our other two parameters. Feed the argument that was passed into the more permanent object data field. So race equals race. And again, those words only look the same to us. By the time that gets turned into assembly language, well, this class sheet does get defined. Part of the reason we do that on its own thing is if I open up File Explorer real quick and go to where this is saved. So I only made 2 files, but you'll notice there's 2 files and a folder here, the Pi cache. And in the Pi cache is people-cpython-37. We can see over in the type. It's of type compiled Python. So class definitions do get compiled. That's why we typically define our classes in different places that we're going to use. It also means order doesn't matter. Did I do that anywhere up here? I didn't do it up here, but like I call the get name method here, even though it's not defined from down below, because it's a compiled thing, not an interpreted thing. This doesn't necessarily get run. Classes don't get ran one line at a time, the way most of the code we've written this semester is. It actually gets compiled. So we usually don't do them in the same place. And then now just to express this point, I'll override the string method. Hopefully all that stuff about the equals method and all that makes sense. It carries right through. The only difference is those without the underscores, we don't need the getters and setters. We can access the values directly. Return self.name is a plus self.gender. Wait, I did self.race plus person and is plus self.age plus years old. So just kind of a sentence there. Concatenation should all make sense. Age is an integer. Age is an integer, so we have to turn it into a string. But that's all things we've seen before. And in particular, we saw this earlier with the underscores, and it threw an error at that point. Said, well, there is nothing called name. Actually, we can see it from the highlighting here. In the class we're working in, there's not any, the reference value name is not written anywhere in there. Name is all the way up there in the parent object. But if we come over here and make one, let's say David, I haven't used that name yet. These names are not referenced on anybody. I don't see any that match our class roster. I am just completely making these names up. They don't refer to anybody. So David is a new citizen. We'll just bypass the parent and go to the child object. Name is David. And even if we pass them in the right order, it's a good idea to go ahead and fill this in. If we're staring at lots of code and doing big complicated things, it really can be helpful to know which parameter we're filling. And if we've made the objects, then we definitely know what all the parameters are called. sometimes when we're using stuff somebody else made, we might not know the name of the parameter and have to pay attention to the order very closely. But if we know it, it's better to use it. Age is 54. Town is Sellersburg. Gender is M. And race is white. And now if we just print that, that's what gave us an error earlier, right? Said, oh, the citizen object doesn't have anything called name. But here we'll see, we can see it worked fine. And when we do this way, we don't need the getters. Print David.town. We can just access that data directly. Much easier to work with. Conceptually, it's just like everything we just saw. Does anybody have any questions about that? That one's a little easier. The book covered that, so I mostly wanted to talk about that underscore stuff because you will see it out there, that way you're not confused about it. And we talked about a lot of the general concepts there. If we do it this way, we can access it directly, and we don't need all of our getter and setter methods. That was kind of strange in the book because they used the completely open data that we always have access to, and then turned around and made it acted like it was restricted. So we do have a style we can restrict it in. So if you use the underscores, which is generally better format, but I mostly wanted to show it so you're not confused with what's going on when you see that in reference material or tutorials or something. If we do it this way, we can just access that stuff directly, and then all we would need is methods that apply to the object. Let's change that. So like David.town is now, maybe he moves to Jeffersonville. Then if we print that, so we have full access to it. You can see we can just immediately get to it. Much easier to work with. Hopefully that makes sense. You just have to remember to put a dot everywhere, basically. And if you do the other type of import, don't forget your library name. You have to say which library that came from. This one where we run it is an interpreted file. And we just saw that this one where we designed it is a compiled file. So it's better to keep those separate. Keep our interpreted and compiled stuff separate if we can. It won't crash if you do. It'll still run. Two different types of computer instructions. Two different types of machine instructions. We haven't done anything with a some sort of letter define. All we've done is override. So I'm going to, before we finish this example, I'm going to do some generic method. Alphabetical order, we need to know what the first letter is. Alphabetic placement. So I'll make a method that's not an override, and that's just going to grab the first letter of the name. So once again, our first parameter needs to be the thing we're designing, which typically we use the word self. You can call it whatever you want, but you do have to be consistent. If it's passed in as a parameter, you have to use it there through that whole method. So standard to call it self, that's what's going to change colors in most of your text editors and IDEs. Return self.name. We already saw that we can access that directly because it's public data and the children inherit the public data. Actually just the first index, isn't it? I was about to do something way more complicated. We just need the first index, and that tells us where it goes alphabetically. Does that make sense? Do you want to see other examples, or can you extrapolate from there? At this point, it's just like what we've already seen with functions. The only thing that's new is you have to pass in that self parameter, and then use that self parameter to get your data. From the work I've seen this semester, I feel fairly confident that everybody in this class can extrapolate from that one example and know what to do. It's what we've already been doing. There's just one little addition to it. Then we can call that method, which I'll just print it out. Call David dot alphabetic placement, which was quite a bit. And it's good to have descriptive names, especially if we have predictive text and we just choose it off the list. Like that. And so you easily grab the first index of that, but we already knew how to grab the first letter out of a string. We've seen the return keyword. We've seen how to define a function or method. The only thing that's new is that keyword self. So, we made a little library, some objects that can be reusable over and over and over again. Some standard human data, right? I was like, okay, that's a really nice library. Maybe some other people might want to use this thing. In that case, we need to document. And well, surely by now, especially those who've had other programming courses, didn't have had somebody other than me for SDEV 120 or seen it elsewhere. You've probably seen big deals made out of comments and noticed that I never use comments. And that's because, well, if we think about what the language is, all these instructions we wrote, that's just a text file. The only advantage calling it .py gave us is that it changes color correctly. We could call it .txt, and if we tell the interpreter to run it, and it recognizes every instruction in there, it will run it fine. The .py just really just changes colors to make it easier to work with. It tells the computer to show this icon, tells the computer to use the Python icon. And then if we double click on it, which is going to stop quickly. So let me x equals input. Press any key to exit. Let me pause that. And that .py extension just tells the computer that if we double click on this to run it with the Python interpreter. We get that same information, and now it's waiting on input. Nothing happens after it gets that input. That's a quick way to make those pause. An easy way to make those pause if you need that. Oh, not any key, press enter to exit. So we got this library. We're going to document it so that other people can use it. And that's where that thing I sent out comes in. So there's lots of them. Right? The instructions are just text there. Our comments, the normal intro level way to document a code, is just text. So if this text, if we send that to the Python interpreter, and the Python interpreter ignores comments and does something with these instructions, there's nothing stopping us from sending this somewhere else that will ignore the Python and run instructions out of the comment and read only the comments. Right? The regular Python interpreter ignores comments, reads Python instructions. So we can just as easily send it somewhere else that reads comments and ignores Python instructions. So we can do two things in the same text file. And that's what we normally do to document stuff. We don't put comments just in there. comments are just like random to-do lists and things like that. Which we did see one of those, right? We saw that comment, we say act to do more stuff. We get this special symbol here. And we get a new button up here under source. We get a button that'll go right to that line of code where we said act to do. So the only thing we can do in our comments, those are called annotations. They're built into the language, not the IDE. That's Python. But there's lots of different places we can run that. PyDoc is a very popular one. Works with Python. There's a number of them. NumPy has some stuff for nice documentation. There's quite a few of them, but one I like to use is this thing called Doxygen. This was originally for C++ language. That's what I sent the link out to today, but this now knows, it's expanded. It knows lots of languages. I used to use several different ones. I'd mix and match them. I'd use PyDoc, which is the same one. The official Python documentation is written in for Python, and then Java doc for Java, different ones for Lisp, and whatever language I was in, I would use different ones. But Doxygen knows lots of languages, and we can map it to a new language on our own. That's where I really started using it for like microcontroller, Arduino microcontroller, and SBC. So Arduinos and Raspberry Pis, to document those scripts, Doxygen worked better because I could rewrite it to the language and the libraries I was working with. C, Objective-C, C#, PHP, Java, Python, there's one we need. A whole bunch of these things. All that stuff's built in and more. They haven't updated their documentation in a moment, it looks like. And it will just generate documentation. So you can see lots of things to click around on, things to get started. It's a big, huge site to dig through. So I'm just going to search for the thing I want. Python and Doxygen. So it went to like some tutorial and Stack Overflow. The third one down looks like the official site. I'm going to go to that. That's not the one I wanted. Well, maybe I will go to the official site because I know where it's at on there. Under manual. Documenting the code over here on the left. If you go there, you'll see what it's requiring. It's asking for special types of blocks. Talks about those. So there's an example. So if you've seen C family stuff, multi-line comments are / asterisk, and then several lines later, or wherever we put asterisk / to close it. So to make a Doxygen comment, we do 2 asterisks at the open, and it's going to look for that symbol. Or we can do asterisk exclamation mark for multiple line ones, and it'll look for those. Or instead of 2 backslashes in the C family, we can do 3 backslashes, and it will look for that and look for the instructions that it knows in order to generate a web page. So a bunch of examples. I've been here a few times, so I know it's all the way at the bottom. A bunch of different languages. I guess they have updated this. It was at the bottom last time I went there. Oh, there's Python. So here, we know that the hash key, the pound sign, the number sign, lots of names for that symbol, whatever you want to call it. I'm gonna call it hash key. We know that one hash key is a comment symbol. So if we do 2 comments and then there's that ampersand or at symbol again, not ampersand, at some keyword. And it looks like we have that a few places. Two of those, and then those special instructions. And when we have a single line, it's just 2. So 2 of those, I usually put just 2 of those, and then put the words on the second line, and then start describing it third. But that's where you find those at. If you go to doxygen.nl/manual, and then over on the left-hand side, you'll see documenting the code. And under, or it was just that page, wasn't it? Oh yeah. On the left-hand side, look for documenting the code, and down near the bottom. Or you can see right there, doxygen.nl/manual/docblocks.html. And this is full of links. So we're going to use this one a lot, @param. I'll click over here. So you click on one of those commands, and here's some, and here's the list of all those. There's an overall list too. Let's scroll up. Special commands. So you want those 2 links on the left-hand side. One of them says documenting the code, and the other one says special commands. So here's all the instructions we can put in. They use \, but in Python we use the @ symbol. \ might still work, but I'm going to use the @ symbol because that's what I'm used to. So like @p does something here, or @end internal, @in verbatim, or verb include, verbatim inclusion. Some of them are abbreviated, but I'll use the @ symbol. There's more than one symbol, and it's written in the documentation there. But we saw the starting point. So to document this, we need 2 pound signs on one line, and the next line needs 1 pound sign. So that will document our class or a method. So we have a class or a method right before it. Just use 2 pound signs and then 1 pound sign on the line. And if we have just a variable, a single line, just do the 2 pound signs. So now what do we put in here? Basically just what we want to say on the website. So a class to represent some generic classroom example data. And here in our initializer, we have 3 parameters that we need to fill in order to access that. So in our documentation, we want to make sure and explicitly state what those parameters should look like. So there's our description of it. So I'll add another line, and we keep adding lines. We have to have at least 1 with just 1 symbol, and then we keep adding lines, and they'll all go together until we get to the thing we're actually documenting. So it starts here and then reads all the way until it hits the Python instruction, and then all of this will get turned into something. So we have some parameters. So we use the keyword @param, and we want to say like what type it is, or well, first off, the name. So the first parameter we pass in is called name. We're expecting a string. And then we can keep tracking after that. So at param, the reference value, what we called our variable basically, what type of data it is, and then the rest of this is just a description. We don't need the dash there. I just put that in there. I'll leave it off. The name of the person. And each of these instructions gets a line by itself. Then we have a parameter called age. It's an integer. And person's age. Then we have a at param called count, which is going to be a string. And usually when I do this, especially in Python, instead of actually spelling out the data type, I like to just use the same thing we use in the casting. So instead of writing out string, I'll write str, which has shown up in this class. That's not actually the name, right? It's character text data. So instead of writing that, I just write str because that's the method we use to cast into that. So if we're passing something else in, we need to turn it into a string. Or int, because that's the method we use to cast to an int. That's how I like to do it in Python. The only thing that we're restricted on here is that this keyword. It's looking for the keyword. The thing after the keyword is the reference value on it. And the thing after that is the data type. A string or where the person lives. And out of habit, I wrote a dash there. I just always like to do that in my documentation. Not really sure why. It's not necessary. So I'll leave it off here. For our single value, the numerical representation of how long this person has been alive. I wrote a nice long description there of what age means, as if somebody didn't know that. Because the restriction is it has to be one line. We can't do multiple lines on a variable. We can do multiple lines up here, and we'll see before long. It generates a web page, so it does know some HTML text. There are some that are blocked because of internal usage things, but it does know a lot of them. At least your most common ones. The H1 through H6 levels, B for bold or strong for bolding text, normal italicizing, paragraph, and it knows quite a bit of the tag, quite a few of the tags, because it's going to generate a website. So if you know HTML, you can throw the tags in there along with those random words. Make it look a little better. Then when we get down to a method, I'll just do one on the string method. The textual representation of this object to be concatenated into grammatically correct sentences. I don't think I made a grammatically correct sentence. I just put some words there to get through the syntax. But we can document that. Same thing with all our getters. I'll put something on one of the getters. So 2 hash keys to say we have something, hashtags, say we have something, and it's a function, so we need to come down and do some stuff about the function. So on the next line, we can just write a description of it. Retrieves the value of the place where this person lives. And then the other keyword, if we're sending something back, we saw what it is when we send stuff in up here, parameter. And if we're sending stuff back, we want to use @returns. So it'd be nice to start with those two. I'd really like to see this in some of your some of the work that remains. This is a very, very useful thing. So you want to jump into this very quickly. And then in future classes, if you have an instructor that's very strict about putting comments everywhere, go ahead and do these type of comments because it does fill the regular comment requirements. Just you can do a little bit more with it, which we will see very shortly. So this returns a type. I'm going to adjust that after we run it once. Yeah, I'll just return the type value. Won't necessarily give it a name, but the name, what it is in the description. And then all of these methods would kind of get documented like that. So you get a comment on every single one, so that if somebody's looking at the text file, they see those comments saying what it is. I'll come down here and do this one so that we have at least, whoops, a couple things. Once again, 2 hashtags to start out, then 1 on the subsequent lines where we pass in what we want to, the instructions we want for Doxygen. Oh wait, this isn't the one I wanted. Well, I'll do it here. Child class of person that adds a few more details in. Once again, we have a couple parameters. We have gender, which is a string, I'll say M or F to represent gender. At param. There's nothing restricting that, so just to avoid offending anybody, I'll add, is it T? Does anybody know if that's the appropriate one? I've seen a T and a U written out. But I don't want to offend anybody, so I'll go ahead and include that. I guess at that point it's going to offend some people will be offended at that being included. So maybe O, not a 0. I'll just add a few things in there. Options for gender, TON, or I don't know what I'll write to make that non-offensive. Single letter representation of a person's gender. That way the person that fills it in can decide. And I don't have to worry about whether the documentation is going to offend anybody or not. So our next parameter is ethnicity. It's going to come in as a string and the person's race or ethnicity. Put both of that together. I'll go ahead and comment this one because it's just that pattern over and over again. 2 hashtags to start it. If it's a class or a function that would have more than 1 line, we need 1 hashtag on the subsequent lines. And if it's just for a variable, then just the 2 hashtags and everything has to go on that 1 line. So let's see. The easier to use version of a Python class with the same data as person, as a person object. And then we have a couple parameters. At parameter name is a string. What to call this person? At param age is an integer. Number of years since this person's birth. And I decided to go with this because hopefully that data kind of makes sense. This is our typical data. I use that as generic classroom examples because it's something that should be quite relatable. And then an object, hopefully you can see how it's a virtual version of the real object. The real person we're representing in our program, whether it's an employee, a patient in a medical field, a customer, it's a virtual representation of it. It's a enclosed thing, right? All name, age, and town. Like for me, Chris, 43, Clarksville, those aren't separate. Those are things about this thing with the video camera pointing at it right now, right? So hopefully that I was thinking that data might make it easier to kind of see the encapsulation. What we need about the object that's being represented virtually is all included as a single item, just like the real person that's represented. It's a single item when we think about it. We don't think about the name and then think about everything else connected to it. We think about the person and then remember their name and then other details about it, right? So kind of, it's like we can kind of think like a human again, is the nice thing about object-oriented programming. Where was it? Oh, yeah. Where this person lives. Something that returns things. Oh, and then again on functions, where does this person show up when things are put in alphabetical order? And our other keyword, along with param, is at returns. And what really matters in the at returns is what type of data it is. That way, whoever uses this, the programmer who uses this later, knows whether they or not they need to cast this data, if it's not the type they need already. Right? If we're returning, like in this, instead of, we use D in an example, if we decided to return 4 for the 4th letter of the alphabet, instead of a D, that person would know they would need to do some math with that in order to turn it into a string that had the letter D in it for their use. So you at least want to say what type of data gets returned. So that's a start, kind of see the process there. And another nice thing about Doxygen, most of them we have to do from the command prompt or command line. We can do that with Doxygen, but that installer that I sent you the link to this morning also has this thing called Doxy Wizard, which is a GUI for it. So we don't have to go work in the command line. GUIs also come with defaults set. When we work in the command line, we have to set up all the defaults and stuff. So here we just have a form to fill out. So the first thing, it's nicely labeled and everything. Step 1, specify the working directory. So obviously, as this creates a huge website for us, imports pictures, writes a bunch of text files, copies and pastes, does all sorts of stuff to put this together, there's going to be files, temporary files created and deleted. We need a place for that to happen. And just to be on the safe side, well, those names are always going to be computer generated names. So it's probably not going to happen. But just to be on the safe side, it's always a good idea to create a scratch folder for it to work in. Because if you happen to have a file of the same name, when it passes in the instruction, delete the file with this name, it's going to delete your version too. So not a bad idea to have a folder for it to create those files and empty those files out. That way it doesn't, nothing ever accidentally gets deleted. Then we can just kind of walk through here. Step 2, configure the wizard. So go through the form, project name, class example on objects, some sort of synopsis of it. SDEV 140 lecture Example from fall 2021 at Ivy Tech Community College. What version are we on? Oh, a bunch of ones. 111. A logo. I don't have a logo, but that's just browse for the picture and upload it. And now these parts, the source code. Where are we looking for files? So typically, it's a good idea to put everything in the same folder. So all the files we need are in this class object example folder. So go to where your stuff's organized. And if you have subfolders, you want to check scan recursively. It doesn't hurt to go ahead and check scan recursively, even if you don't have subfolders. Maybe you'll have subfolders later. This is a GUI, we can save this. There's a save button up here under file. So that's where we're looking for code. And at the bottom, obviously after we look at the code, where are we going to put our results? So destination, select. It just needs to go in any folder. I'll put it in the same place. And since we looked at GitHub, GitHub does allow us to post documentation like this. It gives us a website to post documentation related to what we stored on the repository. And if it's going on GitHub, it will need to be called Docs. The website they gave us is going to look at our repository for a folder called named Docs with lowercase d. So we want to put it. So we want to put this in here because in a non-trivial example, there's a good chance that this is going on GitHub. So we want the documentation for it to go on that website to GitHub post for us. So that fills up the first page. Skip to the next page. What do we want to document? I'm going to go ahead and click all entities because we didn't document everything. You can just not put comments on things and it won't include those, but I'm going to go ahead and include everything because due to time restraints and the fact that it's very repetitive, we just set up the param and returns for all of those functions. This one doesn't really apply anymore. A while ago, we would optimize for different languages, but several versions later, they just never removed it. They didn't have anything else to put there, I guess. It doesn't really make a difference on the optimization. Just leave it like it is. Or choose one of them, but Python's not on there anyway. So we can document everything. Go to the next one. What do we want? Probably uncheck the box for the search function. I'll talk about why here in just a moment. But well, if you want to be able to search the site, you can include that. But with Doxygen, it's a good idea to uncomment that, and I will talk about the reason why here in just a moment. We're in HTML, we don't need LaTeX. Then just select which forms you want. Probably don't need LaTeX. Plain HTML. Navigation panel is the not bad to have an extra navigation panel. It's going to be over at the left, but it's a website. We can change how it's styled. That's no problem. That's what I was going to talk about in the search function in a moment. So I'm going to put the navigation panel, no search bar. You can change the color, but I'm going to talk about that in a moment. The change color button is here because Doxygen was created before CSS became the standard. And we'll talk about that in a moment. So some of the buttons you don't necessarily need, but that just loads up a color picker. You can adjust it from that. Diagrams. That's this. What's on the board? Did the class diagram, remember I said it doesn't take any intelligence to do this, so a computer can generate that. We're documenting classes, so a computer can write the class diagrams because it doesn't take any intelligence to do that. it only takes intelligence to organize it nicely on the page so that another human can look at it and make sense of it. Because as far as the computer's concerned, it can generate them, but it's fine if they're all up in the top left corner, stacked on top of each other, so we can only see the last one generated. That's where the lack of intelligence part falls apart, because we want another human to see it. So the computer can make it, but we need to organize it, because that's like an algorithm itself. So we use the built-in generator, and we're down to the run button. And before I click run, over on the expert tab, you can see there's lots of choices. You can customize that more. Under input, right here near the beginning is file patterns, C, Objective-C, C++, Java. It's trying to scroll me. If I start scrolling, you can see how fast that list is passing by. So you can see it knows a lot of languages already. And there's a plus sign. So we can map new languages that it doesn't already know. That's one of the nice things about Doxygen, is when we mix and match languages, they'll go together. But once it's set up, it knows Python already, so we don't have to do anything there. Just hit run. Oh, it's finished. It's a whole lot quicker than we can make a website, right? Just, computers are great at typing. We probably make a typo when we put a website together, but computers don't. So there's a show HTML button. Instead of clicking that, I'm going to go over to the files. So you can see the scratch folder is already empty because it fills everything up and then deletes all the temporary files when it's done. Cleans up after itself. But a scratch folder is a good idea, because if you have something with the same name that happens to have the same name, it would get deleted as well. And docs, now there's a folder called HTML. And you can see there's a bunch of websites here. And I'm going to scroll down here and point out two things. Right here, you'll see cascading style sheets, a CSS file, the style rules. So there's a CSS sheet called Doxygen, and there's another one down here. Two more actually. A CSS sheet called nav tree. That's that navigation bar option. And a CSS sheet called tabs. And if you select that, include the search bar feature, there's a CSS sheet for that, but there is an issue with that. So 3 CSS sheets, a 4th one if you include the search bar. However, that search bar, when it generates that, several items in it, including the background and the position of it, are set in line. So it will override an external CSS file, which is kind of aggravating. But on those other CSS sheets, you can just save things with the same name, and I already have some saved. I'll point at one on GitHub here in a second. But somewhere in these web pages, you can see there's JavaScript and HTML. Oh, here we go. And an index page. For those who haven't seen it yet, the server, when we put a website on the server, it will automatically look for HTML file called index. This is the first thing it looks for. So here you can see there's the nav bar over to the left. I don't usually include that, but we saw there's just a style sheet for that. Oh, and here we go under classes. Namespace is a way of categorizing our code. We haven't really seen that. It's like the main page. We go to the class list. So here's the classes we created. Alphabetized, and you'll see they're all links. So under person. Oh yeah, and you can see there on the screen why I pointed out the style sheet first. I'm guessing that's probably not what you want your documentation to look for, but that's just styling. That's just changing the colors, the positions of stuff. So here's our diagram. It matches the one on the board. Individual inherits from person. See our diagram, which those are links. But here's that stuff we put in. A description of what it is. We said, and then there's that at param. We said at param. Let's flip back and forth through the code. So like at param name, str, what to call this person. So you can see how it formatted that. It made a list called parameters, something in bold, the type of data it is, and then the description. And we can add things in there. So that was one of the first things I was going to change is that doesn't really stand out. So I'm going to add in the italic HTML tag around the type to make the data type stand out more. It knows some of our HTML tags. Oh, I didn't put a type on town. Italicized SDR. If you haven't had HTML yet, don't worry about that. But if you have, hopefully that'll make sense. Wait, that's like the string. It was a string. So notice that I left the word string off, but it did figure out that it was a string and put that in there. So actually typing it in there will override what it figured out it was. And a whole lot of work's done for us, right? The other thing we documented down here, the toString method. The textual representation of this object, yeah. That description we wrote in there. Up here's where it said, somewhere there's a return thing. Okay, yeah. Here's the other one we documented, the town returns a string type data, describes what it does. So you can see all that stuff is right there included. Or was I just at, oh, here in that return, be nice to see that bold so it stands out a little more. So I'll do the same thing here. I'll come over here and wherever that return was, I'll add the HTML tag in there. Because other programming languages are just text. It can read text. It's just replicating the text. And since it's going to a website, if we put HTML tags in there, the browser will know what to do with it. It's not, Doxygen doesn't necessarily know them. They just don't get in the way of anything. I guess is the way that should be stated. And all that documentation is ready. We can have links everywhere to jump back and forth between things, the list of it, the descriptions, all from the comments in the code. That's way better than just an arbitrary comment, right? Have an entire website. And with DoxyWizard, we have a save button. So that as the project progresses, we can just keep updating that. I'll save it right here in the same place. Call it Doxy file, that's a good name. And then run it again because I added those HTML tags in. There we go. We're going to reload this. Oh, that's not where I added it. Added them over here. Oh, that didn't work. I guess it overrode that. Did the bold one work? Okay, the HTML tags aren't working, unless it's just reading from the cache. Let me see if it's reading from the cache. Because I've done that many, many times, so I don't know why that's not working. I was wanting to open this anyway. Empty cache and reload. Okay, I'm not sure why the HTML tags aren't working. I've done that quite a few times, but they don't seem to be showing up on there. But moving on, the main point is that you can see it's there. And for the style sheets, you can just take things with those names and start setting up your own CSS sheets, style rules to make it look a little different. And obviously, it's a style sheet you can copy and paste. So don't do it right there in that folder because it would be erased the next time you did that. So in another file, make things with the same names as those style sheets and have that on my GitHub in a few places. Yeah, if I hit show more. So Francis-Chris5 is my name, and that TK interface example we did, I'm going to move to the classroom examples when we look at where the delete button is on GitHub. If you ever wanted to use that for reference before or later. Useful Python tools has a couple things. Those getters and setters, and just a class in general with all the underscores. There's some stuff in there that will automatically generate all that code for you. And you just kind of have to pass it some parameters to set that up. Might make it a little easier. I think this one has Doxygen. So two of the game engines that I really like to use with Python are entirely text-based, but the drag and drop interfaces are kind of nice. That's what this is. So I've been putting that. Instructions here. I don't see a link. Ah, here it is. So here's the link to that. So this was also done with that same generator with Doxygen. The search bar here is problematic because they did not, parts of that, the placement up here in the upper left-hand corner, or no, it's in the upper right-hand corner, and a blue background is hard-coded into the HTML tag. So it overrides the CSS. So when I made new CSS files with these different style rules for the way I wanted this to look, so it was, all this was generated and then just swap out the CSS file so that it doesn't look like this. Looks more like the typical Python notation without the logo there. That logo is specific for the project. But yeah, a couple of the Python game engines I like are purely text-based, but drag and drop interfaces are easier to work with sometimes. So I made one of those that writes the Python scripts, so I can still go in and edit them. And that's what, but I documented it with Doxygen and just changed the style sheet on it to make it look different, which obviously is something we only have to do once. It can be a little time consuming. Oh, yeah. And instead of using their style sheet to start with, because it has a lot of stuff, including things that are not showing up in this Python documentation, I just went to the inspector and hovered over elements to see what they call them. So like that has an idea of title area. For those who have seen CSS before, if you haven't seen it, I believe it's a required course, so you will at some point. But just went through there, and the stuff that I wanted to change, I just looked for the ID on it and wrote a new style sheet, saved it somewhere else, and then every time I generate code, I copy and paste it in there. You might want to do that. unless you just really, really like the way it looks, that's up to you. But that is a quick, easy way to get documentation. And that's what you need to do with the comments. You need to write comments that do stuff, not just arbitrary text that's not going to do anything except sit there for the rare event that somebody looks at your code. Does what we did there make sense? Really, it's just put the correct type of comments in and then fill out this form they gave us. And hit a run button, and it will generate an entire website for us. You saw how many web pages are there? And CSS files and JavaScript files, HTML files. There's got to be at least one image file in there. I saw an image on there, but it makes it a lot easier to document your project. Or for things like user manuals, which is a requirement on your final project. Those sort of generated comments would be very nice to see. And we can save it and all of that stuff. I will send those out as an example. That did take about 20 minutes longer than I thought it was going to take. Does anybody have any questions about the auto generator thing there? Does it look like something useful? Something you will be able to make good use of? I hope so. That was what I had on the agenda for this evening. Unless anybody has any questions, that leaves us on a scheduled time where I will be ready to answer questions. I'm pretty sure I'm the only person on campus right now except the security guard. So I'm going to go ahead and drive back to Clarksville. So there'll be like 10 minutes. But after that, as soon as I get back, I will put my laptop back and my video setup is still in place from the afternoon class. I will throw my laptop over there and can jump on a Zoom call to answer questions in a split seconds time. You can ask me questions anytime. That's what I'm going to be doing from now till 9:50 is sitting by the computer in case you ask questions. Text messages and heavy learn messages make noise on my phone. Otherwise, everybody have a great weekend, and I will see you on Monday for our last evening in class with just some random odds and ends that I think you will find useful, like Doxygen. It seems a useful thing. I wanted to include that. Y'all have a good one.
Thank you. Have a good night.
Thank you. Good night.
Bye.